droplets form, why insects can walk on water, and of course, why bubbles exist. It's the elasticity of this skin that allows a bubble to form and maintain its spherical shape. Meanwhile, gas solubility plays a significant role in the formation of these tiny bubbles. Gases are more soluble in liquids under high pressure and less soluble when the pressure is reduced. When pressure decreases rapidly, the gas trapped in the liquid can't dissolve as quickly, leading to the formation of bubbles. Now, what makes nano and microbubbles different from larger bubbles? The key lies in their size. Because of their minuscule dimensions, these bubbles have a high surface-to-volume ratio. This means that they have more surface area available for gas exchange, making them incredibly stable. Larger bubbles, on the other hand, have a lower surface-to-volume ratio. They are unstable and tend to rise quickly to the surface due to buoyancy, where they burst and release their gas into the atmosphere. Nano and microbubbles, however, being so small and stable, can remain suspended in the liquid for a longer period, providing a sustained delivery method for any gases they might carry. These smaller bubbles also have a unique trait. Their internal pressure is higher than that of larger bubbles. This is due to the Laplace pressure, which states that the pressure difference across the surface of a bubble is inversely proportional to its radius. The smaller the bubble, the greater the internal pressure. So, nano and microbubbles are not merely smaller versions of regular bubbles. They are incredibly stable, stay suspended in their liquid medium for longer periods, and have a greater internal pressure. They are a perfect example of how altering scale can fundamentally change properties and behaviors. With this understanding, it's clear why these bubbles are not just ordinary air-filled spheres. From the lab to the hospital, nano and microbubbles are making waves in the field of medicine. With such promising potential, these infinitesimal bubbles are reshaping the way we approach healthcare, specifically in drug delivery and ultrasound imaging. The beauty of nano and microbubbles is in their diminutive size. These bubbles, if you can picture it, are smaller than the diameter of a human hair. This small stature allows them to navigate the intricate labyrinth of our bloodstream, much like a submarine traversing the ocean's depths. But these bubbles aren't just on a sightseeing tour. They carry a precious cargo, drugs intended for specific areas of the body. Now, imagine the bloodstream as a vast network of highways, with the bubbles as delivery vehicles. The conventional method is akin to dropping packages from an airplane, hoping they land at the right destination. But with these bubbles, it's like having a GPS-equipped delivery van that can navigate to the exact location. This means the drugs can be delivered precisely where they're needed, enhancing the effectiveness of treatments and reducing side effects. But that's not all. In the realm of ultrasound imaging, nano and microbubbles are lighting up the screen, so to speak. When injected into the bloodstream, these bubbles respond to the ultrasound waves, creating a brighter, more detailed image. This could potentially help doctors detect diseases earlier and with greater accuracy. So we're not just talking about a small improvement here. This is a paradigm shift in medical treatment and diagnostics. The potential applications are vast, from treating cancer to diagnosing heart conditions and so much more. We're at the precipice of a new era in medicine, an era where we can target diseases with laser-like precision, reduce harmful side effects, and catch health issues earlier than ever before. And it's all thanks to these tiny but mighty nano and microbubbles. Imagine a future where targeted drug delivery is the norm, all thanks to these tiny bubbles. Scene script. Beyond healthcare, these bubbles are doing their bit for the environment and our food. Diving into the environmental sector, the role of nano and microbubbles in wastewater treatment is nothing short of revolutionary. Picture this. Instead of relying on traditional energy-intensive methods to treat wastewater, we now have these tiny bubbles coming to our rescue. Here's how it works. When nano and microbubbles are introduced into the wastewater, they attach themselves to the pollutants. As these bubbles rise to the surface, they carry the pollutants along with them. And once they reach the surface, the bubbles burst, leaving the contaminants behind to be easily skimmed off. This process, known as flotation, is not just efficient but also environmentally friendly. reducing our reliance on harmful chemicals. But that's not all. In the world of science.